Okay, today's learning target. We can find the average rate of change of a function algebraically. Oh my goodness, that's the best thing ever. Now, if I want to find the average rate of change of a function f of x, which is x cubed minus x, over the interval from 1 to 3. Okay, so I'm going to find the average rate of change over this interval. That's when x equals 1, which is right here. That's 1. And here's when x would equal 3. 2, 3. All right, I want to find the average rate of change. I don't know, from this point and to this point. Yes, and that's really pretty much a slope from here to here. That's all we're doing. Okay? Now, f to the x plus h minus f of x all over h. We've been using this for a little bit, but when we're finding the average rate of change, we can kind of consider that a change in y over the change in x. Because h really describes the change of my independent variable. H really is like the change in x. So I can make a little star here and say that's really like the change in x. Now, we are given a change in x right here. When it is instantaneous, there is no change. That's when we got to kind of try to factor that x, or that h in this case, out. We don't have to do that here. We are given a change. So, I like to work bigger number minus smaller number, just as they say positive. So on the bottom, if I have my change in x, I would say 3 minus 1. All right? And on the top, it's f of 3 minus f of 1. That's like a change in y over the change in x. Okay? Nothing crazy. Just to make sure we're still recording. So, who can tell me what is my value? I hate to write everything out because we're so smart. If I put a 3 in here, in for here right here, I've got 3 cubed minus 3. Okay? I'm going to subtract, putting a 1 in there. It's 1 cubed minus 1. All over 3 minus 1. All right? So what is the top left parenthesis going to end up equaling? Stop it. Multiply it by itself. So add 3. Yeah, it was 27 minus 3. So I've got 24 minus, well, 1 minus 1 is 0, all over 2. So I got 24 over 2, which is 12. The slope of this line is 12. And that's the average of all the slopes for each point in between. Meaning, if I put a point here, that's not quite as steep. I put a slope here. You see what I'm saying? If I averaged all those values for all those different slopes, it would be 12. It's the average from 1 to 3. All right? So ultimately, it's the slope from the points where x is 1 to x is 3. Easy. Easy. Okay? Good. Now, I don't think that was very difficult at all. Did I have a picture underneath here? No, I didn't. I got crazy for a second. All right, well, why don't you guys do the same thing? Find the average rate of change of the function f of x, which is x cubed plus 1, over the interval from -1 to 1. All right, I'll give you guys 2-3 minutes. We'll go over it. Bang. All right, so I'm hearing -1 and +1. So what 2 points, okay? When x is -1, which is right here, and when x is +1, which is right here, right? That's this point here. First of all, is that a positive or negative slope?
Positive.
So you should get a positive answer. That's why I always like to put the bigger numbers first. Meaning, I have 1 minus a -1, don't I? And then on top, I've got f of 1 minus f of -1. So let's do all this poo-poo. When I throw a 1 in here, 1 cubed plus 1. 1 cubed is 1 plus 1. is 2, right? So this will be 2 minus, okay, what happens when I cube a negative 1? It stays negative 1. What's negative 1 plus 1? All over, well, this ends up being 1 plus 1, so it's 2 over 2, which is 1. Bam, I like to see the dabs. Probably. It's probably the calculator, not the user, definitely. Okay. All right. So, not difficult, not crazy. Correct? Not crazy. All right, good. Good, good, good. And by the way, that slope of 1 is the slope of this line right here that connects the 2 points. And that's the average. That means, well, look, if I put a point right here, the slope of that line is like pretty flat. But if I put a point here, the slope of this line goes this way. So if I put one right here, that slope goes this way. At different points, you get different slopes. But if I average those all together, it would be 1. It would be 1. All right? Now, let me help you with this one, children. Find the slope of the curve for f of x. All right? And the function of f of x is 1 over x. At the point where x equals a. So we're going to start putting an a in for all of our x's. How come? They tell us x equals a. They don't give us a number for x anymore. All right? Where does a slope equal negative 1/4? What happens at those points, and at what point 1 comma 1 over a for different values of a? Let's just worry about finding the slope of the curve of this at this point first. We can answer all that other junk afterward. And guess what? We're still going to use our favorite quotient. All right? We're still going to use that. Now, I know that x equals a, correct? So the first thing I'm going to do is I'm going to say, okay, it's the function of a plus h minus the function, we're going to put an a in for this x as well, all over h. At the point, right at the point is instantaneous, isn't it?
Yeah.
Yes. This is instantaneous, so they want instantaneous slope, not an average over 2 points. Which means, you see this? I'm going to have to put that in for my x here. Well, hold on. If it's instantaneous, I got to find this limit as h approaches 0, don't I? Instantaneous, there is no change for x. It's right at an instant. There's no change. Which means I got to somehow get rid of that h in the bottom. All right, let's do this. If I have, I'm going to write this up here so you guys don't get confused. If I go fast, you're going to get confused. If I take f of a plus h for 1 over x, doesn't this go in for my x? So really, that's going to be 1 over a plus h. That's not confusing, right? See, I had to break that apart separately. These are all things you know. We're just going to go through them. And if I don't re-explain or remind you what they are, you guys go nuts. Minus. Now, what's the function here when I just throw an a in it for x? 1 over a, because x equals a, right? So I throw an a in for that. It's 1 over a. All over h. All I did is still the limit as h approaches 0. Now, when I first went over this, Sienna, it bothered me the way they did this, but it's mathematically correct. And I'll explain it to you. When I'm multiplying this, I'm going to break this up. I'm going to break up this fraction I have here. I'm going to take 1 over h and multiply it times 1 over a plus h minus 1 over a. How come I could do that? Because if this is technically over 1 and I multiply them together, don't I multiply my h times my 1 for the bottom here? And then my 1 times this whole parenthesis, that becomes my top. I can do that. I can break that apart. And that's going to make this a million times easier. And you're going to be like, this wasn't easy, this. And I'm like, well, you should have seen it the other way. So now you understand what happens here. Now remember our little butterfly thing that we learned in pre-calc? I'm going to combine these two. So I got to find a common denominator. I got to multiply this times a and this times a. I got to multiply this times a plus h and this times a plus h. Because I want to combine those. I want to get rid of that minus sign and just combine them. My common denominator is a and a plus h. So both fractions should have a times a plus h at the bottom. Okay, you guys got that? You guys follow? Okay, so let's rewrite this. I have 1 over h times, well, 1 times a is a, over a times a plus h, okay, minus, now I'm going to multiply these, but don't forget, it's a negative 1 I'm multiplying. That was a negative 1.
Negative 1a.
Well, I got to distribute it, so it's minus, okay. That's going to be, we'll put it all over. Do you want to see? I want to skip steps here. Okay, let's just do minus, and we'll leave this, just multiply these two. That is a plus h, all over a times a plus h. We ready? Now I can distribute that negative sign. We'll do it really one step at a time. Now when I distribute this negative sign, I get negative a minus h, don't I? So when I combine them, I get 1 over h, and again, I'm showing you every step of the way. I want to do all these myself, but I'm showing you. Times. Well, what's going to happen on the top here? I got a positive a, it's going to cancel the negative a, isn't it? And I just have a minus h, don't I? All over a times a plus h. What can I do right now? I can multiply. What else can I do? I can cancel out the h from the bottom, can't I? Can't this h cancel with this h? And I'm left with a negative 1 here? Okay. Let's keep on trucking. Why is that important? So I've got now negative 1 over a times a plus h. Because my h is still approaching 0. If I put a 0 here, no good. I can put a 0 here. What's a plus 0? What is 8 plus, not times? What's 8 plus 0? It's just a. Anything plus 0 is itself. And what's a times a? That's your slope. Now, that was a little bit more complicated, but that's it. That's it. How do I get the a squared? My bottom is a times a plus h. My h turns into 0. What's a plus 0? It's a. So now I've got a times it's a, which is a squared. All right? So if my slope is 1 minus, or 1, negative 1 over a squared. I'm going to scroll back up here. Now scroll back down for a second. My slope, right here, is 1, negative 1 over a squared. They want to know, well, where does the slope equal negative 1/4? So where will this equal negative 1 over 4? Well, guess what? The tops are the same, aren't they? So I got to figure out, well, when does a squared equal 4? What would the values of a be?
Plus or minus.
Thank you. A can be plus or minus 2, and we know our a is the same as x, right? So where does this slope happen? When x is plus and minus 2. Craziness. Craziness, isn't it? So I'm going to scroll back up, and we're going to take a look at our graph, and we're going to look at what happens at positive and negative 2 x values. Oh, yeah, that's the graph. So here's positive 2, Here's -2, right? The slope here, if I draw a tangent line that touches there, and I draw right here, -2, tangent line, both of those slopes are -1/4. And guess what else they are? It's the parallel lines, aren't they? They both have a slope that's the same. So it pretty much happened. What happens at those 2 points? The slopes are parallel. And then what about the point 1a, comma 1/8 for different values of a? I'm not too concerned about that. All I'm saying is that as I get closer to 0 from both sides, like let's say I put a slope here, then it goes like this, right? Say I put a slope here, then it goes like this, right? It gets steeper and steeper, doesn't it? As I get closer to the 0, the slope kind of turns into like a straight line up like this and a straight line like that. So as I get closer to the origin, they go straight up and down. As I get farther away from the origin, they kind of flatten out because horizontal. But that's not as important as finding what the slope is. All right? Wow. Let's walk through this one more time with you guys telling me what to do. They give us a function, x² + 2, and want to find the slope where x equals a. I'm not too concerned about describing what's happening to the tangent, as a changes. Let's just figure out what the slope is right when x is equal to a. So the first thing I need to do is do what? Yeah, I'm going to throw an a in for my x's. So it's f of a plus h minus f of a all over h. Now this is instance. At an instance, that's the limit as h approaches 0. Now, this should always be on this side, okay, on the left side. Which means I'm going to have to plug things in and get rid of the h. This is a lot easier because it is not a fraction. Okay, it is not a fraction. So, let's start. I'm going to put a plus h in for this x right here. So I've got a plus h squared plus 2. Don't forget, I still got to add 2 to it, don't I? That's this right here. Minus putting an a in for x. That would just be a squared plus 2. I'm subtracting the whole function, so make sure you put parentheses around this. All over h. If you've done this right, this will be beautiful every time. Let me explain. I'm going to FOIL this out. I have a squared plus 2ah plus h squared plus 2. Okay? Now I'm going to distribute my negative sign up top. Minus a squared minus 2 all over h. If I did this right, this term right here, which is now this and this, will always cancel out. Always. If it doesn't, you screwed up. What do I mean? Hey, negative a squared, positive a squared. Bang, bang. Hey, look at negative 2, positive 2. Bang, bang. Look at all the terms I have left. What do all the terms I have left have in common? They all have an h. So guess what? I can cancel an h out from every one of them. Bottom, look at 1 here and 1 here. So I'm left with 2a plus h on top. Do I have a bottom? No. Can I throw 0 in for h now?
Yes.
Yeah, because there's no denominator. Don't forget this is h approaches 0. So what happens when I throw 0 in for here? What's 2a plus 0? 2a. That's the slope. The whole magical moment is this right here. When you have your front canceling out with your back, you should have nothing but h's left, and it will just cancel one h out from every term. So I have 2a plus h. That should work like that every single time. This is one of the most important things when you're doing this, but it's not a fraction like the first one. Whatever is in the back here will cancel with something in the front so that you only have H's left to cancel the bottom out. Every single time. Every single time. Wait, there's an exception. No, there's not. It should happen every single time. Okay?